Hey everyone, in this video we are going to look at adding the playable character to the game. We're going to use a pre-existing asset. You're going to go to the asset store. You're going to do a search for free animated spaceman. And when you do and you find it, click on the download button and then the import button, and that will create this folder. So feel free to pause the video while you do that and then come back. So once you've done that and you have this folder, you're going to want to open it up. And then you're going to want the prefab folder. And here's the character. Let's drag and drop him into the scene. And a few things. A, obviously he's too big. He wasn't designed for this particular application. That's fine. We can shrink him. So over here in scale, and if you notice the mouse is bigger, people were saying that they couldn't see where my mouse was at time. Just let me know if you think it should go back to the way it was. But in the inspector for that object, you're going to change it to 2, 2, and then 2. We'll slide him over. We'll raise him up. And what we're going to do, we're actually going to push him forward just so you can see what happens. Now, don't worry about that T-pose. That's just because he's not animated in the work scene. When it's actually running, you'll see he's going to be in an idle pose. See, he's like idle there. Okay, so why is that happening? Well, with the object selected, if you come up here to Animator as opposed to Animation, this is prepackaged. This is the way they designed it. So entry is when the object is created, when it's instantiated, and you can see there's this line here saying to go to idle. So there's a bunch of ways that we could do this, but since I don't want to break what they created, just in case we need these at a later time, what I'm going to do, I'm going to just write a single line of code that says, actually, don't go to idle, go to run. So we want that. We want the run animation. So how do we do that? We are going to right-click, create, C#, and we'll call this animcon, so controlling of animation. So we click on the space dude. We drag and drop that, the script. We open it up. We can get rid of the remark statements. Again, the double / means it's not executed. It's just internal documentation. And we said we want this to happen as soon as he's instantiated. Well, the start section executes when an object is first instantiated. So what we're going to do, we're going to say get component. And again, if there's nothing before get component, then you're modifying a component of the object the script is attached to. The script is attached to the spaceman object. So get component. What component? Well, we just said the animator. What do we want to do there? Well, we want to play something. What do we want to play? We said we want to play the run animation instead. Real easy? Yes, and it's about to get, unfortunately, annoying because it's Unity. So now he's running. Perfect. So here's the thing. If I go back that script and try to add velocity, because right now he's not keeping up with the camera, okay? We want him to keep up with the camera. Some would say just parent one to the other. The problem with that is that if one does something, the other does it. So even though it would be a quick fix for them running in sync, if one jumps, the other one jumps. You might not want that. You might find that to be too distracting. If one changes a lane, the other one changes a lane. You might want, in some cases, for the camera to follow the player. So say the player goes up like a ramp, well, then maybe you do want the camera to go up. But you don't necessarily want it moving and jumping all around. That might be too distracting, okay? So that's why we're not just going to do a simple parenting. We're going to instead have them work in sync without them actually parenting and having one inherit the attributes from the other. So, having said that, do I just go back to the script and add velocity? No, because the animation on this, the animator, it's actually making a modification to the Z position to the best of my knowledge. So because of that, if I add a rigid body, and I say, okay, velocity Z, it won't work. So what I'm going to do is I'll show you that, and then I'll show you the workaround, just so you don't think I'm making this up. So what I'm going to do is I'm going to create a separate script. and this one will be called Running Dude. So we click on our spaceman, we add this new script, and yes, you can have multiple scripts. We go to Running Dude, we get rid of this, and again, we do it in the start section. So ready? Get component. We haven't added the rigid body, but we will in a moment. So get component rigid body dot vector, velocity equals new vector 3, and we said it's 0, 0, 3 positive, I believe, is what the camera is moving at. All right, so there's our space dude. The running script is attached to him. We'll add physics. We'll add rigid body. We get rid of gravity, and watch what happens. Nothing. So it's ignoring it. So we get rid of running dude. We get rid of the rigid body. And now what we're going to do is we're going to create an empty parent object to attach this to. And the funny thing is, I've complained about this when you import an object. I said that like when you take one of these and you drop it into the scene and it adds an empty parent. Well, this one it doesn't, and this one you could actually use one. So go figure, because it's Unity. So game object, create empty, and then we'll just attach space dude to it. We click on that new object, and we just do the physics, the rigid body, get rid of gravity, and that gets the script. So that was running dude. Actually, I should have aligned the game object first. Let's break this for a second. So let's put this at, say, 0, 0, 0, and then we will put our space dude at there. Now they're lined up. So now we'll put space dude on that new game object. And can he be seen from there? Yeah. So looking at that, the angle is probably going to be wrong, but I don't want to mess with that anymore because, like I said, that's up to you to decide what angle you want the camera to be at. Okay, so if I didn't make any mistakes, we have our parent game object. It has the rigid body. We shut off gravity because we're not using it yet. We had applied the script, running dude. Running dude, when the object instantiates, get is a 003 velocity, which should match the camera move. Yes, 003. What we might do, on a side note, right now those are constants. They're numbers and therefore they're not changing. We might eventually change these with variables. I might have mentioned this in one of the other videos. We might eventually change this with variables. That way we can change the speed. So if you changed one, you would need to change the other. So if you want the velocity to be 6, you would have a variable here and here, and you would change it. And then when you change the variable, it would change all the instances of that variable. And there we go. We now have a running dude. And he's just going to run into things. Nothing has a collider on it yet, so not a big deal. He might be a little bit big and burly for this. And he stopped running, so we'll have to look at that. There might already be a trigger there. Like it might do a certain amount of laps and then reset. Again, this is the problem when you use a pre-existing model. You have to look for little anomalies like that. The designer might have put something in there for some reason, and then you have to override it. This is one of the reasons why I try not to use pre-existing assets because of this. So if you were designing this from scratch, it wouldn't be an issue. But I suspect that in the animator, there might be something that's causing Hey everyone, Future Mike here. I cut out me babbling because in post-production I figured out what was going on. So the issue isn't with the animations themselves, it's with the transition. So whenever you set up a transition, you either have to set up a trigger, a condition of some kind, like a variable has hit a certain value or a button has been pressed, or you can set an exit time. So that's what's going on. There's just an exit time, so no big mystery. Sorry, I just hadn't done a lot with character animations recently, so wasn't at the top of my game. So that's all that was going on. There's an exit time, which is basically what I theorized, that after a certain amount of time, it was exiting. That's all it is. So that will work correctly now. I'm not quite sure why they did that. Maybe it was necessary to link them all together. Maybe if they weren't together, it wouldn't be part of the package. I don't know, but so we worked that out, and I'm glad I was able to figure that out for you. So if we just go back here and we run this again, you'll see he no longer does the electric slide. It no longer has an exit time, so it just keeps going. Okay, so back to my regularly scheduled rambling. So what's next? Now we want him to be able to change lanes. So what we're going to do is we're going to look for a key press, and then when you press, we'll use A and D because that's usually left and right. So we'll use A and D on the keyboard, and then what we'll do is if A and D is pressed, if either one of them are pressed, then you will change to the corresponding lane. So let's go back to our script. And now since velocity is being controlled by the running dude script, which is actually the parent object, this is where we're going to be looking for the key press. So in the update section, and control tends to be, once again, iterative. You do something that works, and then you go back and you clean it up. So if input, that's self-explanatory, we're looking for input from the player, dot get key. The difference between get key and get key down, get key is true for precisely one frame, the first frame that you press the key down. Get key down is true for every single frame it's being held down. So what's the main difference? The main difference is get key is like if you want something to happen repeatedly, you have to press repeatedly. Get key down is if you want something to happen repeatedly, you only have to hold the key. So like manual versus automatic. So as far as like weapons, like get key would be each press of the trigger. Get key down would be you press the trigger once and it keeps firing. So get key, and then we have to say what key? A. And what we're going to do, get component. This is going to look familiar. Rigid body. Dot velocity equals new vector 3. And let's move at a rate of -1 because this is the x-axis. You're moving left and right, 0, and we maintain that 3. And ultimately, you really don't want to have a whole bunch of these statements. You want it just once. So what's going to happen is, like I said, when we clean this up, we'll eventually get rid of the redundant statements and just like change a variable and then have just a single one at the bottom that combines all the variables. But again, that's not what we're going to do right now. And then for this one, we're going to say if key is D, then it's going to be a positive one. Now, that just starts it. That doesn't stop it. We want it to stop when it gets to the next lane over. So you're going to want to base this on time, and then since we know what the position should be, we can just true it up with a get component transform to make sure that it really is where we want it to be. So what we're going to do is for both of these, we're going to go to a coroutine. So let's create that coroutine. So it's outside of start, outside of update. It's going to be IE numerator and stop lane change. Even though there's a red line, there's nothing wrong. It's looking for something to happen here. So I kind of don't like the fact that it's saying that's an error. You just haven't gotten to it yet. So yield, return, new. Wait 4 seconds. Let's do 1 second. I usually like to explain everything. Don't worry too much about what exactly this means. Just know that you need to type it, and that the upshot of this entire line is that you're waiting a second. It's literally saying wait 4 seconds. How many? You're waiting 1. So yes, you have to type this. Don't worry too much about it. Just know that the system is going to wait 1 second and then execute what's after this. And that is going to be this. Copy and pasting, again, partially out of laziness and partly out of reinforcing that it's not a new functionality. We already looked at velocity. So in other words, we want them to stop moving to the left and right, and we just want them to continue moving forward. Now, we'll see if that works and where that puts it. And actually, I was going to make the mistake that I always make. I created this, but I didn't actually call it. This will never, ever execute on its own. You have to say go to it. So start coroutine, parenthesis, the name of the coroutine, including its parentheses. I can't tell you how many times I've done that. I always forget the start coroutine, and I always forget the double equal sign in an if statement. This just doesn't need an equal sign. So the reason why I didn't mess that up. Okay. So let's see if the 1 second works out good. Pretty solid. So offhand, I don't think I ever looked into it, but I'm pretty sure that, again, it works with the fact that this is one unity block. So a velocity of 1 is probably 1 unity block per second. That's what I was guessing. But what we can do, let's do a quick debug. So this stops it, okay? Then for kicks and giggles, let's see where it is. So debug.log and get component. Now this isn't the transformer I was talking about. This, we're just going to check the position. We're not going to actually change it, but we would use a very similar verbiage, or should I say syntax, to make sure it's in the right place. See, it's exactly -1, so we don't even need a line to true it up. It's exactly, so that proves out my theory that, again, using the whole number of blocks does a whole lot of things for you, and that a velocity of 1 is 1 unity unit for 1 second. And as you can see down here, XYZ, okay, we don't even have to true it up. You might still want to later just to be safe, but as you can see, it is exactly moving to -1, 0, and 1, which I referred all the way back in the first video about how important it is and how beneficial it is to have a play field that exactly matches up to the unity units. So let's end here because I think that's quite a bit that we covered. Like I said, I'll see if I can figure out why it's switching back to animations. In your project, you're not going to have to worry about that because you're going to have it custom made by someone, or you're going to make it yourself. Like I said, it's always more difficult to try to reverse engineer and try to backtrack what someone else did and why they did it. But at least it gives you the understanding of how to switch between animations. We looked at that. And the fact that your animation and your movement are really handled independently. So in the next video, what we're going to do, we'll probably handle jumping, and we'll probably add a new prefab. We'll probably add like a ramp that your character can run up along. And at that point, we're going to be really close to done because we have a world that's being created indefinitely. So it keeps being created. We have a character who's animated and moves through the lanes. And you can move using the left and right keys. Now, what we didn't do, though, we didn't put a control that stops you from going further. So we'll do that because, in other words, you press A and you go left, If you press A again, it's going to go left again. There's absolutely nothing in here that says don't keep going further. So we will have to put a control in here to keep the players from just going off the environment. But again, we got a lot accomplished in this video. I hope you found this useful. I hope that if you have any questions, you can just let me know, leave it in the comments section, and I really do hope you enjoy the rest of your day.